So as their name suggests, red blood cells are actually red, and they're found in the blood. So this is a blood vessel, and that's a blood inside. So red blood cells are found in the blood. But this is actually the end of the story, right? Because red blood cells, even though they're found in the blood, they're actually not made there. They're actually made inside bone, right? So this is a picture of a bone. Not a very good one, but that's a picture of a bone. And inside the bone, you have this cavity in the center of the bone. So much so that if you took a slice of the bone like that, and you were to look into it, look kind of like head on to it, you'd see that on the outside of bone, there's this hard part, this hard white part that we all know about. But in the center, there's this red spongy tissue. And that stuff, that red spongy tissue, is called bone marrow. Bone marrow. And bone marrow is where all of the different blood cells are made, including red blood cells. That's where they're made. Now, even this isn't the start of the story, because the bone marrow is instructed by the kidney to make the red blood cells. So here's the kidney, and the kidney releases this molecule, this hormone called erythropoietin. That's often abbreviated EPO, right? And erythropoietin, so erythro means red, and erythropoiesis, very similar word. Erythropoiesis means to make red blood cells. So erythropoietin is a hormone that's released from the kidney that tells the bone marrow to make red blood cells. Okay, but how does it do that? Well, inside the bone marrow, there's this cell, the main cell, if you will, of the bone marrow is called, this cell right here, it's called a hematopoietic stem cell, right? Stem cell. And this stem cell gives rise to all of the different blood cells. Whether it's a red blood cell, a white blood cell, or a platelet, they all originate from a hematopoietic stem cell. So erythropoietin, released from the kidney once again, instructs the hematopoietic stem cell to form a red blood cell. So the hematopoietic stem cell then develops into an immature red blood cell. That's what I'm drawing in over here. So it's a pretty big cell, right? And inside the cell, there's the nucleus. That's the nucleus right there. And the nucleus contains DNA. So that's the cell's DNA. And this immature red blood cell, this precursor red blood cell, is called an erythroblast. Erythroblast. Okay. And the erythroblast it's an immature cell. Eventually, it matures into a mature red blood cell. And a mature red blood cell is called an erythrocyte, right? Erythro again means red, cyte means cell. So there's a red blood cell. And as you can tell, the erythrocyte looks pretty different from an erythroblast. For one thing, there's no nucleus inside the erythrocytes, and hence it has no DNA. No DNA. Also, you can see that the erythrocyte has no organelles. So it has no mitochondria, no ribosomes. It's given all of that stuff up. So what does the erythrocyte have inside? Well, the erythrocyte has inside of it lots and lots of hemoglobin. And what is hemoglobin? Well, hemoglobin is a protein that binds to oxygen. So we know that red blood cells serve the function of carrying and delivering oxygen. And it's hemoglobin that allows the red blood cells to serve that function, because it's the hemoglobin that actually binds to the oxygen. And you can see that red blood cells are pretty committed to their job of carrying oxygen, because they empty their cell of pretty much anything else, fill themselves up of hemoglobin, so that all they do is carry oxygen. So all in all, this is what the life cycle of a red blood cell looks like. And this blood cell will live for 120 days before it's taken out of commission. So we were talking before about anemia. and how anemia refers to a decrease, a shortage in the number of red blood cells. So there are too few red blood cells in the body. And there are many different causes of anemia, so much so that we could probably spend the entire week talking about the different causes of anemia. But the people who first described the anemias asked themselves a very important question. They asked themselves, is the decrease in the number of red blood cells because there's a problem in making the red blood cells? Or is it a problem of normal, healthy red blood cells being destroyed? So in essence, they drew a line down the middle of this diagram. And that was fun, so I'm going to do that again. Right? So they drew a big line down the middle of this diagram, where above this line, you're looking at anemias that are caused by a problem with underproduction. And below this line, right, you're looking at a problem where healthy, normal red blood cells are being destroyed. So you're looking at a problem of destruction. And we're going to go through the different types of underproduction anemias and the different types of destruction anemias in great detail. But for right now, I'd just like to graze over the different types, okay, briefly. And I like to use really bright colors, so that's good. So minty green. So let's start off with the kidney. So if, let's say, a person was suffering from renal failure, from kidney failure, and they weren't able to produce as much erythropoietin, that would cause an understimulation of this entire process, right? That would certainly lead to an underproduction anemia. What about moving on? What if the bone marrow was sick because it was infected by a virus? So what if it was too sick to produce red blood cells? Or what if it was taken over by a tumor or fibrosis, scar tissue, and it didn't have enough room to produce red blood cells? That would lead to an underproduction anemia. And what if this erythroblast, looking at this erythroblast, you see it has this huge nucleus and it has lots of DNA in the center. What if we didn't have enough precursors to make all of this DNA? Well, that would prevent us from making as many erythroblasts and as many erythrocytes. So that would be a cause of an underproduction anemia. And finally, getting to this erythrocyte, we said that it's chock filled of hemoglobin. And hemoglobin has lots of different components to it. What if there was a shortage of one of those components, right? Or a problem making the hemoglobin? That would be one of the most common causes of an underproduction anemia. Now, those are the different causes of underproduction anemia. What if we had healthy red blood cells in good quantities being released into the blood, but our immune system started to attack the red blood cells, started to destroy the red blood cells? That would be a cause of a destruction anemia. And what if instead of our immune system attacking the red blood cells, what if pathogens such as viruses and bacteria started to attack the red blood cells? Well, that would be another cause of a destruction anemia. And finally, I'm going to complete the rest of this blood vessel. What if we had a situation like this, where you have this blood vessel and there's a hole in it, a tear, and the blood just starts to escape and hemorrhage out? Well, that loss of red blood cells because of the loss of blood would be another cause of a destruction anemia. So that's an overview, a very brief overview of the different types of anemias that we're going to talk about in greater detail later. But one point that I'd like to leave you with is that this division is pretty intuitive, and there's actually a hint that we can find in lab values that helps us to determine whether we're looking at an underproduction anemia or a destruction anemia. If we have a destruction anemia, you can imagine that the bone marrow and the kidney would work extra hard. They would ramp up their processes to compensate for that loss. They would try to pump out more and more red blood cells. You'd start to see, in fact, immature red blood cells being released into the blood because the bone marrow is working so hard and so fast to release new red blood cells. And those young red blood cells, kind of a step between the erythroblast and the erythrocyte, are called reticulocytes. Reticulocytes. You'd see lots of reticulocytes, specifically greater than 3%. Because 3% is the amount that you normally see in blood. If you see greater than 3%, you can assume that we have a destruction anemia. Now, in an underproduction anemia, your bone marrow or kidney could be the problem. So they're not able to compensate by increasing their production of young red blood cells. So you'd see a decrease in the reticulocyte count. So instead of having 3%, which we said was normal, right, you'd have less than 3%. And that's one really quick and easy way to tell the difference between whether you're looking at an underproduction anemia or a destruction anemia.